Hi, everybody. So the question that you see here on this first slide is, can we use the Pythagorean theorem to find the indicated side of the right triangle? Explain why or why not. Well, if we go to plug into our Pythagorean theorem, a squared plus b squared equals to c squared, okay, we have one of the legs is 14, but we don't know the other leg, and we don't know the hypotenuse. That's what we're trying to find here. So we actually have two unknowns. So we can't use the Pythagorean theorem to solve. We can only use the Pythagorean theorem when we have two sides of the right triangle and we're only missing one other side. So we're going to need another approach when we're working with right triangles and we're trying to figure out the length of a side, but we only have one other side. Keep in mind here, we do have angle measurements, and that's going to be important a little bit later. We're going to talk about something called trigonometric ratios, or trig ratios. And we have three main trig ratios. And these ratios are going to become important a little bit later on because we're actually going to use them to find missing sides and missing angles of right triangles. So we have sine, and sine is abbreviated usually as SIN. We have cosine, which is usually abbreviated as COS, and we have tangent, which is usually abbreviated as TAN. Now, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. The hypotenuse of any right triangle is always across from the 90-degree angle. But the way that you're going to figure out which is the opposite side and which is the adjacent side depends on the angle that you're focusing on. The angle that you're focusing on will always be written next to the trig function. So over here next to sine, we have angle theta, next to cosine, theta, and next to tangent, theta. Now, for those of you who haven't seen this symbol before, theta just means an unknown angle that we don't know, that we might be trying to find the measurement of. So here we have angle theta, our unknown angle, and that was mentioned to be our focus angle here in this situation. So across from our focus angle is the side that we're going to label as opposite. Since the hypotenuse is always across from the right angle, that leaves this side over here to be the adjacent leg. And adjacent means next to, so it is the side that is next to angle theta. And if you have any confusion about which leg should be adjacent, just remember it can't be the adjacent leg and the hypotenuse at the same time. If it's the hypotenuse, it's the hypotenuse. And by process of elimination, the side that's not the hypotenuse and the side that's not opposite would be the adjacent side, the leftover side. So now that we have our trig ratios, I'm going to go back to our example over here. And here we have an angle that we can focus on. In fact, when we use trig ratios, you can focus on any angle other than the 90-degree angle. So here, let's just focus on the 40-degree angle because it's given. Across from this 40-degree angle would be the opposite side, so that would be over here. We have the hypotenuse of the triangle across from the 90-degree angle. And the leftover side would be the adjacent leg, the side that's adjacent to the 40-degree angle. So now we have to figure out what we have and what we're trying to figure out. So we have the adjacent leg because we have this 14 feet. And we're trying to find the hypotenuse because we're trying to find the side labeled x. I want to pick a ratio that uses adjacent and hypotenuse. So I'm going to write down my acronym to help me remember my trig ratios SOHCAHTOA. And I'm going to look for the one that uses A for adjacent and H for hypotenuse. And that would be cosine. C for cosine, A for adjacent, H for hypotenuse. So I'm going to set up my cosine ratio. Cosine, and in the parentheses goes the angle that we're focusing on, is equal to adjacent, which is 14, over hypotenuse, which we are looking for. Now, in order to solve, I can just put this over 1, and I can cross multiply my proportion. So I have x cosine of 40 degrees is equal to 14 Now I solve this just like a regular equation to get x by itself. I'm going to divide both sides by cosine of angle 40. And I have x is approximately, let me get my calculator out. So in my calculator, I'm going to type 14 divided by cosine, so the COS button on your calculator, and 40 degrees inside the parentheses. And on my calculator, I got about 18. And I just rounded to the nearest whole number. It was 18.27. So I just rounded to about 18. So x is approximately a length of 18. And remember, when you're using trig ratios, your calculator should be in degree mode. So make sure if you're not getting the answer that I'm getting here, that you hit mode on your calculator and you check that you are in degree mode. So now we see how trig can be useful in finding missing sides. We also have some reciprocal trig functions. So remember, reciprocal just means that you flip the fraction. So the reciprocal of cosine would be secant, the reciprocal of sine would be cosecant, and the reciprocal of tangent would be cotangent. And we abbreviate secant as SEC, cosecant as CSC, and cotangent as COT. We're going to do an example in a minute where we'll see how we actually use these reciprocal trig functions. Let's take a look at this example over here. So we have right triangle ABC with right angle at angle B. AB has a length of 12, BC has a length of 5, and we need to find the trig functions listed. The first one we're trying to find is sine of angle A. Just to remind myself, let me write my SOHCAHTOA over here. Sine is O over H, opposite over hypotenuse. And we're focusing on angle A. So here's angle A. From angle A, we would have opposite, hypotenuse, and adjacent. The problem is I don't know what the hypotenuse is, and I need the hypotenuse for my sine ratio. Well, luckily, I know two other sides of the right triangle. I can solve for the missing one using the Pythagorean theorem. I can go 5 squared plus 12 squared, and then that would give me 169. Square root of that is 13. This is also a Pythagorean triple. It's a 5, 12, 13 triangle. So my sine ratio would be opposite leg from angle A, which would be 5, over the hypotenuse, which would be 13. Cosine, since we're still focusing on the same angle A, would be adjacent over hypotenuse. So that would be 12 over 13. And tangent, once again, of angle A, the same focus angle, would be opposite over adjacent. So that would be 5 over 12. Now our focus angle changes to angle C. So our labeling of our triangle is going to have to change a bit. Since I'm focusing on angle C, the 12 would be opposite from angle C. So this side would become adjacent. The hypotenuse always remains the same because in any right triangle, it's always opposite the 90-degree angle. So sine of angle C would be opposite, which is 12, over hypotenuse, which is 13. Cosine of angle C would be adjacent, which is 5, over hypotenuse, which is 13. And tangent of angle C would be opposite, which is 12, over adjacent, which is 5. Now we need cosecant of angle A. Cosecant is the reciprocal of sine. So I want to find my sine of angle A, which was 5 over 13, and I'm just going to take the reciprocal of that. If I flip the fraction, that would be 13 over 5. And that's my cosecant of angle A, the reciprocal of sine of A. Secant is the reciprocal of cosine. So if I want secant of angle A, I'm just going to take the reciprocal of cosine of angle A. So the reciprocal of 12 over 13 would be 13 over 12. And then finally, cotangent is the reciprocal of tangent. Since we're focusing on angle A, let me take the reciprocal of tangent A. So instead of 5 over 12, when we flip that, that would be 12 over 5. That's an example of using the focus angle to label your triangle, setting up your trig ratios. also finding the reciprocal ratios. Okay, moving along. Yolanda is making a springboard to use for gymnastics. She has 8-inch tall springs and wants to form a 16.5-degree angle with the base. To the nearest tenth of an inch, what will be the length of the springboard X? So here we have our focus angle. We have the opposite side, and we're looking for the hypotenuse. Sorry, that was 8. I colored over it. Since we have opposite and we're finding hypotenuse, that would be sine O over H. So sine of 16.5 is equal to opposite over hypotenuse. From here, we can cross multiply. And then let me divide both sides by sine of 16.5 to get the X by itself. And if I type this into my calculator, because I do need to round to the nearest tenth of an inch, 8 divided by sine, that's the SIM button, 16.5. And I get approximately 28.2 in my calculator, which is answer choice 4. Here we have right triangle ABC. And if I look in the question, angle B is the 90-degree angle. Angle A is 32 degrees. And AC is 6.2 centimeters. We're finding the length of BC. From our focus angle, we're looking for opposite, and we have the hypotenuse. So once again, this would be sine opposite over hypotenuse. Sine of the 32-degree angle is equal to X over 6.2. Let me cross multiply this all. 6.2 sine of 32 is equal to X. Let me type that into my calculator to see what X is. And to the nearest tenth of a centimeter, X is approximately 3.3 centimeters. Okay, if you take a look at this question, we need to find the measure of angle S. So this time we're actually finding an angle. So I'm going to label the angle as theta, which is an unknown angle. You can label it as X, or you can leave it as S, whatever you want. Just understand that we are solving for that angle. And if I take a look at the diagram, here's the opposite side. I don't have anything about that. I do have the hypotenuse. And I do have the adjacent leg. Let me put SOHCAHTOA back here. Since I have adjacent and hypotenuse, that would be cosine A over H. So cosine of the angle I'm finding, I can call it theta, I can call it angle S, either one is fine, is equal to adjacent, which is 60, over hypotenuse, which is 65. We can't just cross multiply here. And the reason for that is the angle that we're solving for is trapped inside of the cosine function. We need to get it out from the parentheses of the cosine by undoing cosine. We need to cancel out cosine. And the way that we cancel out cosine is by using inverse trig. And the inverse of cosine is inverse cosine. Inverse of cosine looks like this. It looks like a little negative first power, but we don't read it like that. We read it as inverse cosine. Now, if I take the inverse cosine of our cosine ratio, since it cancels out cosine, it will give us the angle that made that ratio in the first place. So I'm going to take out my calculator and I'm going to hit the second button, and then I'm going to hit cosine, and the inverse cosine symbol pops up on my calculator. And in the parentheses, I'm going to put 60 over 65 and hit enter. And the question is asking to the nearest degree. So I see to the nearest degree, it's approximately 23 degrees. Now, anytime you are solving for an angle using trig, inverse trig is how you are going to solve your trig ratio once it is set up. So if you're solving for a side, cross multiplication. If you're solving for an angle, you're going to solve using inverse trig. Let's do another example. So here we have right triangle ABC, and it's telling me that the hypotenuse is AB. So let me label the hypotenuse as AB. So C would be the right angle. So the hypotenuse has a length of 26 centimeters, and BC has a length of 17.6 centimeters. This is the measure of angle B to the nearest degree. So angle B is what I'm solving for, so that's going to be my focus angle. So here would be opposite, hypotenuse, and adjacent. So I'm looking for a trig ratio that uses adjacent and hypotenuse because that's what I have information about. And if I write down SOHCAHTOA, that would be cosine, adjacent, and hypotenuse. So let me set up my cosine ratio. Cosine of the angle that I'm looking for is equal to adjacent over hypotenuse. So remember, since the angle is trapped inside of the cosine, we need to undo it using inverse trig. So the inverse of cosine is inverse cosine. And if I take inverse cosine of our cosine ratio, since it will cancel cosine out, it will give us the angle that we're looking for. So on my calculator, once again, I'm going to hit second, cosine button, 17.6 divided by 26. And I'm going to hit enter. And it says to round to the nearest degree. And on my calculator, I got approximately 47 degrees because it's 47.39. So that's approximately 47.